Hi everyone. Today we're going to talk about inverses. We're going to revisit them. We already saw them in section 3.7, but let's talk about what we're going to do in this particular unit. So let me do a screen share here. This is a document I sent out to you. Oops, let's go up to the top here. Okay, so if we recall back in section 3.7, we already studied inverses. Okay, but these were mainly with polynomial functions. In sections 5, 6, 5, 7, and chapter 6, we revisit the idea of the inverse function. Here are some things to remember from section 3.7. First off, a one-to-one function from domain to range and back from range to domain. Okay, that makes something one-to-one. If a function is one-to-one, it has an inverse. You might have to limit the domain of the original function, but it has an inverse. If f of x is one-to-one and the domain is D and the range R, then the inverse of f of x is f inverse of x, that will minus 1 if you recall in the superscript area. And the domain for that is the range for the original function. So the domain for f inverse of x is R, and the range for the f inverse of x was the domain's original function, D. So let's take a look at it in this graphic. So if I have f of x going from domain to range, then I'll take this range, it becomes the domain for f inverse of x. Okay. Send it to its range, which was the original domain of f of x. Okay. To test for inverse, if f of x and g of x are one-to-one functions, and if f comp g of x equals g comp f of x, and they both equal x, then f of x and g of x have to be inverses of each other. Also recall that the graph of the function and the inverse of it are symmetric about the line x equal y. There were 4 main steps in finding an inverse. First, we changed f of x to y. We exchange the x and y. We isolate the y algebraically. Y is the inverse. After we do that, and we change it to inverse notation. So let's take a look at an example. So in section 5.6, we're going to see some rational functions. In section 5.7, we're going to see some radical functions. So let's take a look at a radical function with a square root. This is a cube root, of course. We'd end up cubing both sides. If it was a 15th root, we'd 15th power both sides. Okay? Remember, square roots and squares are inverses of each other. Okay? Keep that in mind. Cubes and cube roots are inverses of each other. With the square root, we might have to limit the domain a little bit. But we still have, as long as it's one-to-one, okay, the square root and the square are going to be inverses of each other. So f of x equals the square root of 3x minus 8. So first thing we do is we exchange the f of x with y. Then we switch out. What's x up here becomes y down here. What's y up here becomes x down here. Okay. We square both sides because it has square root in it. We need to get rid of that square root. So squaring both sides, we get x squared. Squares and square roots cancel each other off, giving us 3y minus 8. We're going to add 8 to both sides to start to continue to isolate the y. So adding 8 to both sides gives us x squared plus 8 equals 3y. Then we'll divide both sides by 3. Dividing both sides by 3, we get x squared plus 8 over 3 equals y. Now that we have y isolated here, following this process, y is f inverse of x. So we use that notation. So what would this mean exactly? If I plug an x in here, okay, so let's suppose I plug 4 in here. Okay. So 3 times 4 gives me 12. 12 minus 8 gives me 4. The square root of 4 is 2. Okay. Let's suppose, remember, what did I plug in here? I plugged what in? A 4. So we got an answer of 2. Let's plug 2 in here. 2 squared equals 4. 4 plus 8 is 12. 12 divided by 3, excuse me, is 4. Sorry about that. That means that what we started with in f of x, we put in, we got a range value, we took that value from the range, put it into f inverse of x, and got what we started with. That's what inverses do. Let's look at an example of a rational function. These are a little trickier. Okay? With a rational function, we go through the process, okay? Change f of x to y, exchange every y as an x, every x as a y. So what was x up here is turned into a y down here. What was y up here is turned into an x down here. Now the algebra part is a little trickier. Okay, we're going to multiply both sides by the denominator, just like we do with any equation. We want to get rid of the fraction. So the denominator is the quantity 2y plus 3. So we multiply both sides by 2y plus 3. This gives us x times the quantity 2y plus 3 equals y minus 7. Distribute 2xy plus 3x equals y minus 7. Subtract y and subtract 3x from both sides. So in other words, I'm going to group the y's on this side. I'm going to group the things without y on this side. That's our first big move here. The second big move is the side with y, factor out the y. So if we factor out the y, that gives us y times the quantity of this expression, 2x minus 1. We'll divide both sides by that 2x minus 1. So whatever's left over in the parentheses after we factor the y out, that's what we end up dividing both sides by. Okay? And that gives us y equals 7 minus 3x over 2x minus 1. So that's our inverse. I hope this helps you out. Have a good day.